Hi, my name is Samantha Shagert, and I decided to do my ideal gas law project on the science of airbags. I chose this topic because I am learning how to drive and airbags are an essential part of the car, so I thought this would be a very interesting topic to learn about. As you can see, I have several images on this slide. The one on the top right and the one on the left show how an airbag would look when it would come out of the steering wheel. The other image says, "Safety isn't just a slogan, it's a way of life." I like what this image says because safety is always the number one priority, especially when driving a vehicle. All of these slides have a good amount of information on them, so I'll just sum each one up. Hope you enjoy! So on this slide, I decided to begin my presentation by giving some facts about airbags. Basically, I said how airbags inflate the moment a vehicle slows down, resulting from an accident. The airbag circuit will be triggered if a car detects deceleration higher than the preset speed. Harmless gas rushes into the nylon bag when the circuit passes an electrical circuit through a heating element. Also, I didn't include this on my slide, but airbags can also cause harm. They exert a lot of force. Sitting too close to a deploying airbag can cause burns and injuries. The people most at risk from death of an airbag include children and small adults because their bodies can't take the force. The first picture shows an airbag inflated in the car. This car has no people in it, unlike the second image that has mannequins in it to show everyone how close an airbag actually is to the drivers and passengers. My third slide has a lot of important information on it. Vehicle airbags work using the ideal gas law. By reacting NaN3 with excess heat, a large amount of N2 is created. The balanced chemical formula for this is 2NaN3 plus heat goes to 2Na plus 3N2. In Boyle's law, the relationship can be expressed as P1V1 equals P2V2. The science of airbags relates to Boyle's law because in an accident, if one hits the airbag pushing it in, which is a decrease of volume, the pressure in the airbag increases. The first picture shows a drawing of two steering wheels. The first steering wheel has labels labeling all of the important parts, including the crash sensor, inflator, airbag, and sodium azide. The second steering wheel also has labels. These include the crash sensor, inflator, airbag, and nitrogen gas. The heat generated causes sodium azide to decompose into sodium metal and nitrogen gas. This inflates the car's airbags. The second picture shows the ideal gas law written in the empirical form. This is PV equals nRT. P, V, and T are the pressure, volume, and temperature. N is the amount of substance, and R is the ideal gas constant. The ideal gas law says that the two sides of this equation have to balance. Adding moles of nitrogen gas forces the volume of the system to increase. This increases the airbag between 20 to 40 milliseconds, which improves the chances of avoiding serious injury. This slide includes the variables. An ideal gas is one that never condenses regardless of the various changes its state variables, which are pressure, volume, and temperature, undergo. The internal variables of an airbag include the massive gas within the airbag volume, airbag footprint area, and the pressure. The constant variable of an airbag is the amount of air that gets pumped into the bag. So for this slide, for my image, I decided to draw an airbag. So I included labels on it, and these say crash sensor, inflator, airbag, and nitrogen gas. The first link includes a video on how airbags work. The video explains how airbags can save your life. Your car has to be able to detect when a crash is happening. Your car has an accelerometer that detects sudden rapid changes in velocity. The gas that fills airbags is produced by a chemical reaction. This example is sodium azide, which I previously discussed in this presentation. Most frontal airbags are installed with guanidine nitrate. The front face of the airbags moves towards you between 150 to 250 miles per hour. Airbags work because of chemistry and some physics. Airbags work in conjunction with seatbelts, so make sure to buckle up. The second video includes a lot of information. Basically, it explains the ideal gas law, and it gives all of the formulas and the ideal gas equation, which is PV equals nRT. I chose to use this video because it is a Khan Academy video, and the instructor talking about it has a lot of knowledge, and he explained all of the facts and details in a way that is very easy to comprehend. For this slide, I decided to make my own example on Notability. It shows the ideal gas equation once again, and the oxygen going to the amount of moles to fill the bag. It shows how the airbag increases to 20 milliseconds to improve chances of avoiding injury. These are my citations. I thought these were all very credible sources to use. My first website had a lot of information and many facts and details, and just a lot of important knowledge that I needed to know about how airbags really do work. Then my second website was my Khan Academy one, and my third website was a .edu website, which those are always very credible and helpful to use. So yeah, I hope you enjoyed watching my presentation because I worked very hard on it and spent a lot of my time on it. So thank you for watching. Bye!